With all of that out of the way, now we can actually go into the process you take to calculate your magnetic compass error, or to find your true compass bearing or heading based off of a known magnetic compass error. It's still a formula, just like with the gyroscopic compass, just like with get, but this one is larger because you have to account for both deviation that we just went over and variation, which we went over just a little before that. So how you read this is C stands for technically PSC, per standard compass, or just SC, standard compass. That means your magnetic compass. Magnetic is still referred to as standard compass because, for the past 1,500 years, we've been using magnetic compasses. So it is still technically the standard, even if everyone actually relies on gyroscopic compasses nowadays. So don't get that confused. Don't think standard is the more practical compass. Standard means magnetic, always. And C means magnetic. Next we have D for deviation and V for variation. M can actually be understood as magnetic heading, which is not the same as the magnetic compass heading, and I'll get to why in a second. T means true, and then plus E means that anytime you're moving in this direction, you add a westerly error, just like with GET. Anytime you move in that direction, you subtract a westerly error, you subtract an easterly error, you add a westerly error. The mnemonic to remember this is, can dead men vote twice at elections? Much easier to remember than CDMVT. Some people know other mnemonics. Some people have it go in the reverse order, and they do TVMDC plus W. That works just as well. It doesn't matter. This is the one I was taught, and this is the one that sticks in my head. So memorize this before you do anything else. Then you can actually move to the calculations. What this all means is that if you have some known deviation and some known variation, you can essentially just combine the two of them, or you can put them into two separate steps, and then take your compass heading and convert it through those two to get to your true heading. Or you could take your true heading, convert it through those two in the opposite order, and get it to your compass heading. The reason we have M in the center is because, like I said before, variation is a consistent, much more predictable quantity. You could essentially, you will never not have this play a factor. You can have zero deviation. You can have deviation not even be relevant to you. Remember, this comes from the result of having a who knows how many thousand tons of steel surrounding you at all times while you're taking these measurements. If that wasn't there, if you were just sitting on a raft in the middle of the ocean with a magnetic compass, there would be negligible, if not just zero deviation, because there's no magnetic anomalies. There's no large pieces of metal or electronic equipment that's impacting the magnetic field in the area. You've just got the true magnetic field. So M stands for magnetic heading or magnetic bearing, because that is what a magnetic compass would read if it were not for the presence of the ship. If there were no magnetic interference in the area, then the magnetic compass would point directly to the magnetic North Pole without any deviation from that. So we put that there to understand that this is technically the more accurate magnetic heading, and then this is the compass heading. So, for instance, let's say you measured something with a compass bearing of 0.86, and then when you later, well, we'll do it this way first. We're saying you're trying to find true. So you measure an object's bearing, and it had a standard compass bearing of 0.86. Now, let's say you know your deviation. You know that your deviation in this situation is 3 degrees west, because you went to your deviation card and saw that it's 3 degrees west for this given situation. You also know that your variation is 11 degrees east because you went over to your chart and you found that in your specific area, in the general operating area that you are, variation happens to be 11 degrees east. East would mean you're probably in the Pacific. So how do we now find what the true bearing of the object was? Well, we take these things one step at a time. So 0.86 and a westerly error of 3 degrees. Well, can dead men vote twice at elections plus east means anytime we're going this way, we add an easterly error, subtract a westerly error. This is a westerly error, so you subtract the 3 degrees, and you find that your magnetic bearing is 0.83, meaning your compass measured 0.86, but 3 degrees of that 0.86 was caused by all of the metal in the ship throwing off the bearing of the magnetic compass. So if that metal weren't there, if the ship weren't present, you would actually have measured 0.83. Now you have to remember, okay, well, we've got 11 degrees of variation, this time with an easterly error. So plus east, you add an easterly error, you get a final value of 0.94. So, okay, you had a compass with no ship around you measuring 0.83, but that doesn't include the difference between the magnetic North Pole that the compass is pointing at and the true North Pole. And you know that in your general area, the difference in angle between those two values is 11 degrees in an easterly direction. So you add those 11 degrees and you find out that the true bearing of the object this whole time was 0.94. Let's work it the other way. Let's say you have a, let's say you study up on a range and you know that this range has a bearing of 320. You know that because on the chart it says 320. Well, now you want to find what your compass bearing should be. Or actually, if we're studying up on it, it would be your heading now. Now you want to know what your compass heading would be. Let's say your variation is 6 degrees west and your deviation is 1.5 degrees west. So now you got to work this way. Well, can dead men vote twice plus east minus west only applies to this direction. So if we're going this direction, it is plus west minus east. So now that we're going this way, you add anything with a W next to it. So you get a magnetic heading of 326. Now going from your looking at the true North Pole to looking at the magnetic North Pole. And now you have a deviation of 1.5 degrees west. Well, you add that as well. So you get 327.5. Easy. It's easy to go both directions. Now, the relatively harder part and the more common thing for you to actually be doing is not going all the way from compass to true or all the way from true to compass. It's starting on both ends and working your way inward, usually to find deviation, because your variation, like I said, is always known. Your deviation could change. So let's say you didn't have your deviation this time. You studied up on the range, a different range, a range that was bearing 245, but your compass showed a heading of 232. Okay. So you know your variation. You always know your variation. Or you will the moment you check your chart. And your chart says your variation is 8 degrees west. Now we need to still find our way towards the center because the one thing we don't know is our deviation. Your deviation card says something, I'm not going to guess what it might say, but it will give some degree value for probably an angle close to that because they usually are broken into intervals of 30 degrees. So it might not have your exact one, but it'll have something close. You still want to either confirm that that is accurate or correct it if it is not. So you start by working this way, 2, 4, 5, 8 degrees west. We're going in this direction, so we do plus west minus east. Now this would make more sense if this was east. You'll see in a second. So you're working this way, plus west minus east, so you have to subtract the 8 degrees. You get 2, 3, 7 degrees. So your magnetic heading was 2, 3, 7 because the difference between the magnetic North Pole and the true North Pole was 8 degrees in the easterly direction. So now you have 2, 3, 2 and 2, 3, 7. Well, the difference is pretty obvious. It's 4 degrees. But what direction is it? You know how to find the value when you're given a direction and you just follow it, either adding or subtracting based on these rules. But what happens when you have the rules but you don't have the direction? Well, you look at which one's higher, which one's lower. You're going down from 2, 3, 7 to 2, 3, 2, just like you were going down from 2, 4, 5 to 2, 3, 7. Anytime you're going down when you're going this way, it is an easterly error. Because anytime you're going up while going this way, which is the same thing, just in the opposite direction, it's also an easterly error. So you can now say that your deviation in this situation was calculated to be 4 degrees east. Maybe you look at your deviation card and it says 4 degrees. Good, you confirmed it. Maybe it says 3 degrees. Well, that's close enough that, yeah, that seems still pretty accurate. Maybe it says 3 degrees west. Now you can correct it because you know you definitely don't have a deviation, a westerly deviation in at this heading. It is east. It's east by about 4 degrees. Let's do one more. We'll find deviation again because it's not realistic to be able to be looking to calculate your variation. So let's say your compass heading was 0, 4, 5 and your true heading was 0, 3, 3. Let's say you had a variation of 12 degrees west, and you're still trying to find your deviation. So you start with the same steps again. You go from your true to find your magnetic. So you're going 0, 3, 3 plus west, because when you're going this way, you add west. So you add the two together, you get 0, 4, 5. I actually didn't plan that in advance. This is interesting though. You have 0, 4, 5 here, 0, 4, 5 here. What does that mean? Your deviation is 0 degrees. Not 0 degrees west, 0 degrees east, it's just 0 degrees. This doesn't mean that there's no magnetic influence on your compass at the moment. It just means that the magnetic influence cancels itself out. Everything that's pulling the magnet to the east is being corrected by something pulling the magnet to the west. Not necessarily that there is no influence at all. But, you know, that's a convenient situation to be in. Your deviation is 0. If instead this was, say, 0, 4, 4, then you would still have another 1 degree difference, and you could label that as 1 degree west in that case. So that's how to use Can Dead Men Vote Twice. Really, the number one thing you need to take away from this, though, is that mnemonic, CDMVT plus E minus W, or TVMDC plus W minus E, whatever you need to remember. Anything here you can realistically figure out on your own. Just remember the mnemonic, remember the formula.